This is the Team 5 Heat Exchanger first prototype video by Joshua Sick, Tori Hernandez, and Veronica Fabiano. Moving into the heat exchanger description, we have a shell and tube design. The cold water will flow into the box through 3 channels and around baffles. Hot water will flow in the opposite direction through copper piping that snakes around through the channels. Heat will be exchanged at the outside diameter of the copper tubing through the cold water. We use 1/8 inch acrylic for the box, channels, and baffles, 5/8 inch copper pipes, and 3/4 inch plastic tubing to fit the copper piping to the 1/2 inch NPT threads. We have an 11 inch by 6 inch by 2 inch box that will serve as the outer perimeter, and we laser cut the acrylic. We used adhesive to construct the box, and we will solder the pipes to the L-bends.
In this clip, you can see how we tested our inlet connection using a rubber tube connecting the threaded NPT and copper pipe. As you can see, the water flows out of the copper pipe without leaking out of the connection point. We only set this up for the hot water inlet for the purposes of prototyping, since this is expected to be the most sensitive point, but is expected to function for the outlet as well. The cold water inlet and outlet are open into the channels without need to connect to a copper pipe.
And here's the heat exchanger running under desired operation conditions. From this test, we were able to get that the hot water inlet temperature was 34.6 degrees Celsius. The outlet temperature was 34.5 degrees Celsius. For the cold water, the inlet temperature was 1.5 degrees Celsius and the outlet temperature was 15.2 degrees Celsius. And this increase in temperature is probably due to the box not being sealed on top, so it was just heat loss into the environment. The hot water flow rate was 1.5 liters per minute for this test, and the cold water flow rate was 0.5 liters per minute. The hot water pressure drop was minus 2.4 millimeters of mercury, and the cold water pressure drop was minus 0.7 millimeters of mercury.
Now for some lessons learned after prototyping. For some areas of leakage, we'll be using more acrylic adhesive and sealant to fix a hairline crevice in one of the corners of the box. We'll also be using more Teflon tape on the threads as a safety precaution for the final assembly, and we'll also be using rubber sealant at the connection points to fully seal them. Some design changes we'll be making as a result of prototyping is reducing the amount of channels due to the L-bend radii of the copper pipes being too large for the channels that we originally had planned. And regarding the hose clamps for the rubber tubing, we will actually be disregarding them as the rubber tubing provided a good enough seal.